Welcome to today's lesson. We're going to be talking about tangent and sum and difference formulas for tangent. You can see these on your formula sheet. I'll put them in front of you here. You have two different varieties. One where you're adding the two angles together and then one where you are subtracting the angles. And this is really kind of up to you and how you set that up. Obviously we have tangent of A plus tangent of B on the top and then 1 minus tangent of A times tangent of B on the bottom. Some patterns to notice is that the sign that's located here in the first part is exactly the same sign as on the top of the fraction, and the opposite sign is on the bottom, right? You can see that happen here as well. So being able to do that does tend to work out really, really well. We can say we'll say tangent of 60 plus 45. And that's going to give us my tangent that totals up to 105 as well. And so putting this into the formula, we're obviously going to be working with this formula here. We're going to say tangent of 60 plus tangent of 45 over 1 minus the tangent of 60 times the tangent of 45. Tip, if I can use 45 degrees or any multiple, any reference angle like 135 or 225 or 315, if I can use any of those angles, I'm going to do that because 45, tangent of 45 is a 1 or a negative 1 depending on which quadrant you're in, right? And that makes calculations very simple. Tangent of 60, if we kind of come over here, I can use my left hand rule or I can just draw out the triangles, right? So here's a 60. Here's my 45. We know that the sides of a 45 is 1 square root of 2. We have 30 here. We have 1. We have square root of 3. And we have 2. So the tangent of 60 would be, of course, opposite over the adjacent, which turns out to be square root of 3 over 1. And then the tangent of 45 here again is opposite over adjacent. This is really nice. It's 1 over 1, so it just gives me 1. So we end up with the square root of 3 plus 1 over 1 minus root 3 times 1. And so obviously we don't really have to do that multiplication. It's just going to be 1, or it's going to be the square root of 3 minus root 3. Now, we don't normally leave our solutions like this. What we end up doing is we end up simplifying that a little bit, and the way we simplify an expression like this is to get rid of the radical in the denominator. We are going to multiply by the conjugate on the top and the bottom. When I mean conjugate, I want you to take the radical, or the denominator, and I want you to change the sign of that denominator in the center, right? So I need to change the radical's sign from whatever it was to the opposite. So since we had a negative sign there, I'm going to change that to positive. And really what I'm going to do is I'm going to distribute in the top and the bottom. The good news is on the bottom here, when I go to do this kind of FOIL process that we're so used to, so we do first, then we do the outer, the inner, then the last, right? When I do all of this product, I'm just going to work it all the way out for you here. So the first one's going to be 1 times 1, and then you're going to have 1 times positive root 3. Then you're going to have 1 times negative root 3. And then you're going to have negative root 3 times positive root 3, which would be negative root 9, which is just 3, right? So that would give you negative the square root of 9, which turns out to be just minus 3. Notice what happens in the center. These two cancel each other out, and you're going to end up with negative 2 as the answer for the denominator. Now, this is the difference of squares. I knew that it was going to be the first value squared minus the second value squared. I knew that it was going to be this, and I knew that I was going to end up with that response. So, with all that said, I have to make sure that I do a good job of that. I don't make any careless mistakes. So 1 minus 3 ends up giving me negative 2. On the top part, I am going to have to kind of FOIL the whole thing out, right? So if we do the first one, that's going to be root 3. The last one is going to be plus 3. The inner one is going to be plus 1. And And the last one is going to be plus root 3 again. So if I simplify that, I'm going to get 4 plus 2 square root of 3 all over negative 2. What I know about this is that I have several values, a negative 2 here, a positive 4, and a positive 2, where I can simplify all of that because they all share a factor of 2. And so if we divide that up, we're going to get the common factor up top would be a 2. That's going to be 2 plus 1 square root of 3 all over negative 2. And we see that the 2's can cancel out. I'm left with the negative 1 on the bottom. I'm going to go ahead and distribute that negative 1 to the top, to both parts. And so I'm going to end up with negative 2 minus the square root of 3. And that is my final solution here. Just like when we did the sum and difference identities for sine and cosine, we always ended up with something that was very similar in nature. And we tend to end up with a value that looks very similar to this in terms of 2's and root 3's. Sometimes it might be a little bit more, but we're going to kind of mix these up with the signs and values looking like that. There is something that needs to be said about tangent. There is a suggestion, a very strong suggestion, is that I should never use a certain angle. So we should never use 30 degrees. We should never use 150, 210, or 330 degrees. Now this is not something I can't do. I can definitely do this, and I'm going to show you why in just a second. If I choose one of these angles when I go over here to write out whatever it is, I'm choosing to use a reference angle of 30 degrees. The problem with this is that the tangent of 30 degrees, or any of these values, is something like 1 over root 3, and that's a fraction. But if I used 60 degrees, tangent of 60 is just square root of 3. It's not a fraction. It saves myself a tremendous amount of work. So I want to do an example now just to kind of illustrate to you why we should never use those angles. We're going to look at a problem. It's the tangent of, let's say, 15 degrees. Now I could say that could be the tangent of 60 minus 45, or I could say that's 45 minus 30. I could use a lot of different things, right? I tend to like to stay in the first quadrant because that means that my sides don't ever go negative, but really any combination of angles that would give you 15 degrees would be good. Now, I would choose that one. I would not choose this one, but I'm going to do that one for you. And just to show you what happens when you choose a 30-degree angle. So we would say tangent of 45 minus 30 is our value. So this would be A and this would be B. So we're going to say tangent of 45 minus tangent of 30, all divided by 1 plus tangent of 45 tangent of 30. Once here, we are going to go ahead and simplify that. We can obviously draw out my triangles. This would be 1 square root of 2. That's going to be your 45s. 30, 60, 90 would be here. We're going to get 1 square root of 3 and 2. So tangent of 45 is nice. That's a 1 minus the tangent of 30 is going to be 1 over root 3. We're going to rationalize that. That's going to be square root of 3 over 3. At least we can work with non-radical denominators or just from the beginning. So we're going to put radical 3 over 3, all divided by 1 plus the same 2, but I'm going to be multiplying them. Since it's multiplying by 1, we're just going to put radical 3 over 3. So I end up with a fraction that looks like this. And what I want to do is I want to basically simplify that expression so that I don't have a radical left. And so that begs me to I need to get a common denominator and work this out. So what we're going to do is we're going to change that 1 to 3 over 3. And that allows me to kind of bring those together, and we end up with 3 minus root 3 over 3. All of that, same kind of thing, but it's plus this time. 3 plus root 3 over 3. And now I have a fraction on top of a fraction underneath a fraction, and I really don't want all that. I'm going to multiply by the reciprocal. So 3 over 3 plus root 3. Here we see that we do get some cancellation happening, and we can simplify that to 3 minus the square root of 3 over 3 plus the square root of 3. Now, to be clear, if I had not chosen 60 degrees, then all of this I could skip over. If I had chosen 60, I would end up here, or something similar to what this is. In other words, there's no fractions. So getting that common denominator and then multiplying by the reciprocal, this is not needed. This is not a necessary step to do. But if I choose that 30-degree angle, I'm essentially doubling my problem. Let me just finish this out. So if you did use any good angle that's not 30-degree reference angles, you would simply start in something similar to where we are right now. So let's go ahead and complete this problem, kind of show you what a normal tangent would look like when we simplified. You can see this, if you go back to the previous example, we kind of started in a place like this. It wasn't exactly the same values, but we're going to multiply by the conjugate and do that again. The bottom, we already know what's going to happen. We're going to square the first one, we're going to subtract, and we're going to square the last one. So that's going to end up with 6. If you FOIL that out, you'll see the same thing happens there as well. We're going to have to FOIL the top. That's going to end up being 9. We'll do the first one. And then it's going to be negative 3 root 3. And then it's going to be negative 3 root 3 again. And then at the end, we're going to end up positive 3. So when I combine all of that, I'm going to get 12 minus 6 root 3. And here again, just like last time, I'm going to simplify this expression to 2 minus the square root of 3. Didn't have a negative to worry about here. So really, if I had just started here, I would have cut my steps in half. There's about 4 major steps in this problem that I just did. But really, I could have chosen carefully, and I could have gotten away with just doing half of the work. So my suggestion, my tip to you is when you're choosing your angles for tangent of sum or difference angles, right? Avoid 30 degrees. A reference angle of 30, that's 30, 150, 210, and 330. If I can do that, I will save myself a lot of work. Okay, we have one other example today, and then we will be done. In this example, we are effectively working backwards. What's happened here is you have a set of angles that have been put into a sum or difference formula. Step number 1 is to identify which formula you're working with, and then you need to figure out what A and B is, and then plug those values back in to see what is it that we started with. In the first example, we can clearly see that it's a sine and a cosine mixed up, right? So this is going to be the sine of A plus B or A minus B. In this example, you can see cos, cos, and then sine, sine. So this is clearly going to be your cosine of A plus B. And then here we're working with tangents, so it's going to be a tangent of A plus B or A minus B. We need to figure this out first so we can know what to plug in. This is the sine of A minus B, because we know that the sines are the same within sine. They're different within cosine. So the example A is going to be 2A, and B is going to be equal to 3B. Okay. In this case, I just used different letters to kind of illustrate what would happen. And if I could combine these like you see in the rest of them, I would combine them. And if not, I may leave them as simply an expression like this. So we're going to say it's going to be the sine of 2A minus 3B. And that would be it. If I could combine those into one value, if that was 2A minus 3A, then obviously this would be negative, or this would be 2A minus 3A would be just negative A. But it's like that, and so this is the answer. I can't actually combine A and B. Let's do it where I can combine it. This is going to be cosine of A plus B. We know that the cosine values, these signs are different. And so if I plug it in, A is equal to 200, B is equal to 50. So we would say this would be the cosine of 200 plus 50. So we are going to end up with a final solution of cosine of 250. And that's how you would look at that one. Tangent, again, very similar. We know that this is tangent of A plus b, because we have the signs are the same as the top. So in this example, we have a equal to negative 3 theta and b equal to 4 theta. And we would say tangent of negative 3 theta plus 4 theta, which really ends up giving us just tangent of 1 theta. And that would be the solutions there. It's about working backwards, about looking at what your formula is, and then finding a and b and plugging that in and simplifying it. If, like this one, we couldn't really simplify, but these two we can simplify. And so those are relatively easy. Don't overlook those, but practice them so that you are comfortable doing them.